So thank you for the invitation. I think a gravity model explains why I'm here very well. So this is joint work with John Cullinan from Galway. John can't be here, as he's just become a father. And with Denny Flannery from Limerick, who's volunteered to answer all the hard questions. Haven't you? So many of you will know a lot of the context, but some of you won't. So in Ireland, third level education access is rationed by second level attainment. There's excess demand for places, and excess demand, particularly in some courses, is very difficult to get into. And so the way we do things in Ireland is there's a centralised clearinghouse, a thing called the CAO, and people in their final year of school fill in a big form, applying, saying what their preferences are, and there's hundreds of different options now. And based on how they do in their leaving cert, that determines where they go. Those of you who know the system will know it's a bit complicated. So for many courses, there are certain restrictions, like you might need to have a C in maths or something to get into engineering, and there may be language requirements for certain courses. So beyond those eligibility criteria, what your leaving cert exams do, your best 6 papers, people typically do 8 or 9 papers. On your best 6, you get a point score. So you think of each subject gives you a maximum of 100 points, so you can get 600 in all. There's bonus points for mathematics. And so how many points you get determines what offer you get from the system. There are alternative entry routes. There are other ways into the system. Things like FETAC qualifications, and there are access programs and so on. So the point system is not the only game in town, but it's by far the biggest. The alternative routes are getting more important, but they're still a small proportion of students. So we want to do what I suppose is a fairly simple kind of descriptive analysis of what makes people successful, or what predicts success in their second level attainment, but we're going to go beyond what other people have done. So there's been a lot of work, fair bit of work in this area. This is a random selection of papers on the subject. Some of it using the same data that we're talking about. The paper by Smyth is a nice paper. She's focused on the effect of grinds. That's what she's about. The work we're doing draws partly on a paper I did in 2010, which is the kind of working paper version of the 2014 paper, but there are some important differences. And then more recently, Dara and I have a paper that's coming out in a book next year, I think, which kind of updates my earlier results. And what we're doing is extending that here. One key finding that comes out of some of this work is that attainment at second level explains most of the socioeconomic gradient at third level. Right? So kids from richer backgrounds are much more likely to go to third level. Kids from richer backgrounds are more likely will do better at second level. That's not a coincidence. Right? And so in my paper in 2010, that attainment and how many points you get in the leaving cert explains all of the SES gradient. And the work that Dara and John have done is not as extreme. They still find some effect of socioeconomic gradient, even allowing for it. Our models are not exactly the same. That result is not terribly surprising, I hope, and there's a similar finding for the UK. And that has interesting, important policy implications, because people talk about universities having an equality program that people from poorer backgrounds are less likely to go to the third level. And the reason for that is nothing to do with the third level. It's the problem begins earlier. When I say explain, I should say it's the proximate explanation. It's the fact that poorer kids don't have as many points explains why they don't go to the third level. What the ultimate explanation is a harder question that goes back. We don't know what that is, but it's a proximate explanation. So our research question is who does well in the Leaving Cert? Who in terms of their characteristics, but also who in terms of how they do. So let me explain.
Well, Kevin, isn't there another issue of who takes the Leaving Cert? So you have basically more or less all kids who take the Leaving Cert go to third level.
Yeah, we're looking at
kids don't do the Leaving Cert.
not that many.
No, not many kids.
I think about 80-something percent.
Yeah, that's a lot.
80% of that lot, yeah.
Yeah, but 20% don't. That's
yeah. Okay. Thanks for that. So, what standard regression models, we're looking at some continuous outcome, does is they look at the mean. Okay, so
it's not me.
I called out Dave earlier about this. What did it start? So imagine we're looking at some outcome. So it could be earnings, it could be points, doesn't matter. Let's say it's something that's desirable. And we're thinking of some binary treatment and intervention. So here's one possibility, okay? You have a control group, and then the people who get this intervention, this is the outcome for them, and you can see what's happened is that the treatment just shifted that distribution to the right. And so a regression is great for looking at this, right? Because all that's happened is the distribution shifted to the right. And there's no point in doing anything else, you're just comparing the mean. Okay? So if in that situation you're fine, just do OLS. Here's another possibility. So again, this intervention, this variable, whatever it is, has increased the mean, you can see. But there's something else going on here, which is that the right tail has moved out a lot, and the left tail hasn't moved out that much. And so a regression will pick up the increase in the mean, but it won't pick up this change. And you can see that inequality will have increased here, right, because the thing has spread out more. Okay. So regressions are great in their own right, but they don't tell you everything, or they may not tell you everything depending on depending on what happens. So some of you will know a technique was invented in the late 70s, quantile regression models by Professor Koenker and Bassett. And what these do is they're more precisely called conditional quantile regressions. So they model conditional quantiles, the quantiles of y conditional on x. So if you just think of the median case, as the easy example, 50th percentile, the interpretation of these is less straightforward because the median of y given x is not the same as the median of y, as just the median of y. Okay, so somebody could be very high up in the income distribution, so Philip here is loaded, he's got a lot of money. Well, conditional on his education and his experience, well, it's not that surprising. Okay, so in the conditional distribution, he's not going to be as high. The second thing is that the interpretation of these is subtle because let's say you have a model, you're modeling the median of y given x1, and then you think, well, I'll change it, I'll add in another variable x2. By changing the x's, in a sense, you change the y, right? Because the median of y given x1 and x2 is a different animal to the median of y given x1. So these models are widely misinterpreted. I would say roughly half the papers I see using this basically think that they're looking at the median of y, when in fact they're looking at the conditional median. And how you interpret that is kind of not obvious. So an example of this, this issue was brought to mind some years ago watching The Simpsons. And as you know, or you should know, in Simpsons, the bus driver is a guy called Otto, who's a kind of stoner and heavy metal fan. And at one point, it's discovered that he doesn't have a driving license, which you might think is a bad sign for a driver. And he offers the following defense: I stand by my record, 15 crashes and not a single fatality. So, you know, given that he's had 15 crashes, I suppose you could say that's not a bad record. But my guess is you don't want this guy driving your kids. So we're not necessarily interested in conditional medians and so on. So a couple of years ago, some econometricians invented a technique that allows us to look at the unconditional quantiles. I learned about this through Elena. Elena Matza is a PhD student here. I hadn't heard about it. She told me she was using it in her thesis. And what this does is it allows you to provide estimates of the marginal effects of covariance on the quantiles of the distribution. And if you think about it, you know, for lots of things, if you're looking at earnings or attainment, we want to know, you know, does an effect help? You know, it matters whether it helps the people who are doing fine to begin with. A lot of interventions, we're more worried about what happens in the left tail, the people who are badly off. So it's important to know what parts of the distribution are affected. Now, this approach can be used to do lots of other things, as well as looking at quantiles. A quantile is just one distributional statistic. So you can use it to look at things like the variance, the Gini coefficient, an entropy index, pretty much any distributional statistic that you can think of. But we're going to be just looking at quantiles. There's other papers in this area looking at quantile effect, unconditional quantile effects. Froelich and Melly is a paper in the kind of treatment effect literature. It's a different approach to the one that we're going to be using, where you have a binary endogenous treatment. It's a non-parametric approach. So there are other papers in this area, but what we're going to do is based on the Firpo et al. Paper, which is Econometrica of 9. So this is based on a thing called an influence function. And this is something that's used in statistics in looking at things like robustness. You know, how robust a statistic is to say something like a measurement error or outliers. It's called contamination. And influence function is the influence of the ith observation on a given statistic. But what we generally work with is what's called the recentered influence function, where you just add the statistic back. So the recentered influence function for the mean is just the observation itself. So in a sense, you've been using recentered influence functions all your life, because when you run a regression, you're actually looking at the recentered influence function. For the mean, it doesn't really matter. What it is technically is something called a Gatto derivative. So what you have is, you have a distribution of some variable, and based on that distribution you have some statistic which depends on it. And you're asking, what happens when we move that distribution in the direction of another distribution? So it's what you're talking about is not a function, it's a functional. And there's actually really interesting history behind Gatto, French mathematician. So what essentially we're doing is approximating a Gatto derivative. So what you do is you calculate the recentered influence function for, in this case, a quantile, but you could do it for a Gini coefficient. It's going to be a binary variable. It'll be a dummy variable. It won't be 0 or 1. And all that matters is whether the observation is above or below the quantile. Right? So unlike the mean, where it matters how far you are above or below the mean, with a quantile, it only matters whether you're above or below it, because it's a rank order statistic. For a quantile, the influence function has this slightly strange form. So let's say you're talking about the 40th percentile. So tau is 0.4. The influence function will be tau minus 1 if the observation is below it, and 0 otherwise. Hey. So what you do is you calculate these influence statistics for your quantiles of interest. So it's a binary variable, but it's not a 0-1. One thing you need is a measure of the density at the quantile you're interested in, median, 40th percentile, whatever like. Of course, you don't know this exactly, so you estimate this from the data. And there's an issue there, as ever, the choice of, so let's say you're using kernel densities. Choice of kernel doesn't really matter, it never does, but the bandwidth can matter. And we haven't explored that at all. But work from other people have shown that the choice of bandwidth, and the sample we're using is not huge as well. The choice of bandwidth, and particularly in the tails, can be an issue. So we're flagging that's an issue, but we haven't done anything about it yet. Yes. So you have this binary variable, and what you can do is basically you just run an OLS regression. So it's a linear probability model. That's not the only way of doing it. You could use a logit, or there's non-parametric methods. The evidence of Firpo et al. Is that doesn't seem to matter, at least in their application. So the data we use is a School Leavers Survey that ESRI collected on behalf of the Department of Education. The papers that I did used School Leavers Survey for about 8 years, from the 90s, around the time on either side of the abolition of university fees. And this is the last year. Unfortunately, the data isn't collected anymore, but it's a great shame because it really filled a gap. So this is the latest that's available. It's a stratified random sample of school leavers. It's collected 9 months, about 9 months after they leave school, and it's useful. You have their how they did in their last exam. You know what they did thereafter, where they went. If they went to third level, where they went. You know if they're working. If they're working, you have data on earnings and stuff like that. I've worked on this as well with Cullinan. And you've got kind of some reasonable demographics. You've stuff on kind of teacher quality, but it's subjective. It's based on what the student thinks of their teacher, which, as an academic, of course, I don't believe in. And then we've mapped in, or Darrow and John have mapped in some school characteristics. What we don't have, what we'd like to have, we don't have, is any measure of kind of prior attainment, like some measure of their ability. So in some sense, we can't do a value-added function as opposed to a gross output function. So this is just the means of our variables. So the mean of points is 344. All these variables are actually dummies. There's in principle lots of variables that we could have put in, and it's a kind of a choice, it's a kind of a judgment about putting in things which are definitely exogenous, things that might be exogenous, things that might not, and we're going to just show you one set of results, but we've looked at others. So we're interested in socioeconomic background. Now you have data on social class and on parental education. And what we've settled on is just to look at whether the mother or father is third level graduate. In the work I did, I used a socioeconomic class one. We could look at all education levels, but for simplicity, we've just picked this one, because this actually does a lot of the work. So it's not the only way of doing socioeconomic background, but it's the most straightforward.
Kevin, the age, whether they're just aged over 20?
Yeah.
That's a joke, okay.
Yeah.
So you don't know, with transition year, you can't really tell whether it's just because transition year is either a year older.
Well, transition year wouldn't get you up to over 20, I think.
No, but I mean,
It could be.
Not knowing their age, you don't know whether the effective transition year is simply because it delays them doing the Leaving Cert by a year, or whether what they learn in the transition year helps them. See what I'm getting at?
Repeat that. I think I do, but go on.
So, if you do a transition year compared to not doing it, you'll be 1 year older
Yeah.
than doing your Leaving Cert, right? So, if the transition year is a positive effect, is that simply because it delays you a year, or because you've learned so many useful things in your transition year?
Yeah. Yeah. I mean, I don't know. I think in the data that I used, the earlier data I used, you had age by year. Well, in this version, it's banded for reasons we haven't quite figured out. We may be able to get the original, more granular data.
Do you have junior cert results?
No. So Smyth had junior results. She was able to get that from the Department of Education. I'm not sure how she managed that, but that would help. So what I'm going to do is just show you some densities before we do the analysis. And because there's lots of coefficients in the tables, I've printed off the table of regressions.
Does that have the sample size? I'm just curious.
It's 1,078. You lose with pairwise deletion. You do lose a fair bit. That's one of the reasons. If we put in more socioeconomic variables, you start to lose more. So it was kind of a trade-off between reducing sample size more and more. So here's the density of points, just broken down by male and female. And you can see that the girls do better. On average, it's about 10 points better. But what's interesting is that the left tail is pretty much the same. Left tail is pretty much the same, and why girls do better is because you're more likely to find them in the right tail, kind of at the expense of the center of the distribution. So in some sense, if you're not a good student, it doesn't matter whether you're a boy or a girl. Male. So one thing we look at, which we found quite interesting, is students are asked, do they have a disability? And they're also asked whether their mother or father has a disability. And this is the distribution for those, for whether their father is disabled or not. Now, thankfully, not many students do have a father who's disabled, so the numbers are relatively small. You wouldn't normally draw density for something with relatively few observations, but it's the easiest way to pick. And so you can see that kids who have a disabled father, their distribution is to the left. So we're going to quantify that, but that by itself.
What's the definition of disabled?
I think they're just asked. So I'm not sure.
Degree or whether
There's not just a binary.
work or
I have to check. I think this is a binary. Does your father have a disability? This is by whether the father has a third level education or less than the third level. And you can see kids with more educated fathers have higher points, and it starts right at the bottom and up. I won't show it to you for the mothers, because the picture for the mothers is almost identical. You'd be hard pushed to distinguish between them. And this is for whether kids did grinds or not. And in this case, the right tail is pretty much the same, but where it differs really is kind of between the left tail and the center. Okay, so here's the results. So what we've got is, so you'll see half the table at a time, but you've got all the table. We've got the OLS coefficients, and then we've just looked at the 20th, 40th, 60th, and 80th percentile, because that's as many as you can fit in. I will show you graphs when we look at every, a much more detailed breakdown. So, you know, in some cases, if you take actually...
One of those days.
I looked at it crooked.
You did.
It lasted longer. You reckon after about 5 minutes. Like, I got a bit longer.
You had a break. You had a break.
Yeah.
We all have to.
Hmm? Okay.
Oh, yeah.
Actually working on the middle screen.
Yeah.
It works on that one. It stops working up here for some reason. Yeah, we're back.
Okay. So just to take the first one first. So being female, other things being equal, is associated with getting about 20 more points in your leaving. But the effect is smaller and not well determined at the bottom end of the distribution. And if you remember the first graph, briefly click back to it, that kind of fits in there. You see there's no real gap there.
Presumably, if you put in confidence intervals, this wouldn't be so clear cut.
True, yeah. But I mean, in some sense, that's what this is allowing you. That's what this is telling you. Right? Here you have confidence intervals.
Well, not for testing the difference across the...
Oh, of course, yeah. You'll see, well, I'm going to graph these things for you and with confidence intervals. So you'll see. So one of the things we found is that so students who have a disability do worse, but once you start controlling for anything, it's not significant. So the raw difference is significant at, t is about 2. But as I said, once you start controlling for anything, that effect goes away. But what we found quite striking is that having a father who's disabled is a killer. Okay, having a father who's disabled is going to cost you, on average 66 points, and that effect is particularly big at the lower end. Now, the good news is that not many kids do have fathers who are disabled, but if you do, 100 points is, and if you're familiar with the Irish system, knows that is a hell of a burden to carry.
What's the interpretation of this? Clearly, just all the breaking is leg or your leaving cert is not going to necessarily adversely affect you.
Well, that wouldn't really count as disability. I mean, it's not sickness. Having a father who's disabled.
I guess it could come through multiple channels. It could be through the labour market activity, or
that's what I was trying to get at.
Yeah, or
what disabled means in this context.
The kid is helping out. The kid has to help out at home because father's disabled.
Could be some genetic relationship, right? That you're more likely to be ill because your father's.
I think that's very unlikely.
Most things are genetic, right?
No.
I mean, most things are intergenerationally correlated.
Yeah, that's not the same as genetic.
No, I know that, but it is true that most things are intergenerationally correlated. So there's probably some relationship between your health status and your dad's health status, for whatever reason.
But your own health status, your own disability doesn't matter.
Right, but there could be other aspects of your health.
I'm
just wondering in terms of the interpretation.
Are there gender differences in the impact of father's disability on performance?
That's a really good question. So what would you predict? Or have I told you this already?
You haven't, but I mean, if you think I would say that the girls are probably going to be helping out more at home if it's a helping out at home thing. So it's going to hurt them more.
Spot on. Yeah, it's really a girl effect.
So that's not genetic then.
Yeah, it's mainly a girl effect. would suggest that girls feel obliged or pressurized to stay at home and help out when dad is sick. So the socioeconomic factor, again, you know, there's big effects. It's a bit bigger for father than mother. And it's kind of lower at the lower end.
Just one more before we leave the disabled fathers. Is it blood for the girls? Is it just because they stay home, or is it because they actually don't and they have to work to compensate? Is it a labor market entry for
We don't know.
Okay.
Yeah.
Any question like did you work prior, or did you work in something?
I don't think we know whether they have part-time. You mean like if they have part-time
Sometimes
jobs?
it's it's sort of like this might be a fairly common question that they would ask.
There is a question, and there's a question actually about whether you worked
Okay.
while you were taking your last state exam.
Okay. I didn't know that. It was a good question. Yeah. Yeah, sorry, I never hadn't occurred to us yet. Now, so again, some of you will know that a lot of students do what's called a transition year, which is a year in between the junior cycle and the senior cycle. So the junior cycle, you do 3 years, you do a statewide exam called the junior cert. And then you do this transition year where you, some kind of non-academic year, and do various good things and so on. But you know, that's generally chosen at the school level. So that's probably, you know, it's as much a reflection. I mean, I suppose we think of it as probably a proxy for school quality, rather than the effect of the transition year per se. This is whether the kids went to a fee-paying school. Not many do, and it doesn't predict higher scores. So
how come all our students come from fee-paying schools?
Well, you know why? Because they're South Dublin. You know, it's just that
very.
yeah, but it doesn't help their points.
No, I think it's a proximity thing, right? Yeah, a lot of people go to school near home.
So middle class parents. I mean, fees are a normal good. So you're much more likely to be to go to fees well off. But those kids have other benefits.
But it is interesting. It's not showing up here that you.
Yeah.
Election or not, that you're not finding that people in think schools are doing better.
Yeah. So there's another paper. So we're not the first to find this. There's a paper a couple of years ago by 2 Israeli statisticians who, bizarrely enough, chose to look at the role of fee-paying schools in Ireland, looking at PISA scores. So PISA scores would be their math score when they're 15 or 16. And they find that there's no benefit once you control for stuff. That there's no benefit to. I mean,
It's a common finding.
a lot of parents, I can clearly think that they're buying good points, good results when they send their kids to school. And there's some school in South Dublin. I remember seeing they literally had an ad on a lamppost down the N11. I forget which school. It wasn't Blackrock College, but it was one of those. Such a college for points and personality. That was it. Send your kids to our posh school and points and personality. So it may help with their personality, but I don't think it helps with their points. So they're wasting money.
But the coefficients are not so small, no? It's just that it's not very precise. So I mean, the absolute value of the coefficients are not so.
Yeah, I mean, I suppose. I mean, because of the way the system works, I mean, 30 points could make a big difference, you know, in the sense of getting into medicine or something like that. So that the marginal return to a small number of points in terms of getting your object of desire could make a difference. Yeah.
But what I mean is that for this graduate matter, like the coefficients here were like between 40 and 50. Okay, between 40 and 50.
Yeah. So, I mean, if you're like having a mother and father graduate is worth over 100 points. That's huge. That more or less kind of fits in with, say, the results that I got a few years ago. I mean, that's a big gradient.
So, Kevin, maybe this is a stupid question, but see, your total n is 1078, right? But for quantiles, is the n, the fact n of cases 1078, or is it?
No, it's not like each regression is just looking at the people. Each regression uses the whole sample.
So your standard errors are reflecting the fact that you're using the whole sample for each of these, even though you're getting 4 separate coefficients. So it's not like you say, well, we take the bottom 10%, we run a regression there, and make the next 10%. It's not like that, no. Yeah. And the standard errors are bootstrapped with about 400 applications. But you are generating 4 separate coefficients.
Yeah.
Yeah. So what we've done here is run those quantile regressions, but at a more detailed level. So at the, I think it's called quantiles, right, the 5th, 10th, 15th, up to 95th percentile, and graph the coefficients with their confidence intervals. And in here we've just put the OLS line. So the OLS is a constant effect. Rather than putting in confidence bands for that, it gets very cluttered. So just to give you some clue, we put in the T ratio for this OLS, so you can get some idea of where the confidence band would be. And so again, this kind of fits in with what we saw earlier, that at the lower quantiles, being a girl isn't an advantage or disadvantage. Once you get above about, into the kind of beyond the first quartile, there's a kind of a constant benefit. It tails off a wee bit at the end. The age effect, and so as kind of Dave Rose, the age effect is kind of hard to interpret. It's people who are doing their leaving cert and going in, doing their leaving cert older than normal, and that can be for a couple of reasons. So it could be that they've repeated. It could be that they did the leaving cert and failed, they come back again. It could be because it took them just 3 years or something to get through some particular level. So there's kind of something's gone wrong, I think would be the fairest. And so here's a case where, just looking at the OLS, would miss the fact that, so remember, 0 is up here, okay? So for students at the top of the distribution, being a more mature student isn't such a disadvantage. And so maybe that, you're so smart, it's not such a penalty. Down here, you're such a poor student, it's not such a penalty. But it's the median that's affected, rather than the tails. There's nothing to see there, really. Here's the effect of having a father disabled. Now, again, here you can see at the top of the distribution, having a father disabled, I guess these kids are so good, so determined, that it may not be such a barrier. But it's at the lower end, towards the lower middle end of the distribution is where this penalty is kicking in. Socioeconomic effect is kind of funny. It's mainly in the middle of the distribution. At the lower end, having a low educated father or having a high educated father isn't such a benefit. So it's what the socioeconomic status is doing is it's kind of bringing up the middle and to a lesser extent the right end of the distribution.
Could what's going on here being that dad being a graduate means different things at different ends of the distribution? What? So again, this is the intergenerational stuff again, that for very smart kids the chances are their dad is a certain type of graduate. For less smart kids it's more likely their dad is a different type of graduate, right? From a different type of institution or something. So it's a different treatment.
I suppose it could. Well,
because it is quite coarse, the variable.
Yeah, now we have the socioeconomic status variable, which will pick up on occupation. So if we use that, so you'd know
that might shed some light on that, actually. I haven't thought of it. Yeah. So that, I suppose, will give you a more subtle interpretation of this. You use something in addition on occupation.
Similar thing about this, the age plus 20 could also maybe be that the kids that are above 20 but are doing really well are above 20 for different reasons than those that are above 20 but not doing so well. That could maybe also is a similar treatment. I was wondering if you could add to these graphs some just a summary of the distribution, kind of. So where are these guys, the plus 20 guys? I would guess.
Where are they in what sense?
In the raw distribution of scores. The distribution of scores.
So in other words, right, if you have somebody at 90 percentile, but there really aren't any 20 plus people at the 98th percentile, what is that really telling you? I mean,
Yeah.
you do point out that you use the whole distribution, but when you estimate it, it might seem a little odd to say, well, having a being plus 20 doesn't hurt you at the top, but then you discover there is nobody age 20 plus at the top.
Yeah, there has to be some because we're able to get
Right, exactly.
there must be some because we can get some precision on that.
Sure.
Yes.
It could be that they're very specific people.
Yeah. So that's much the same as the scaling is different. In case you're wondering, do they look different? That's because that one goes up to 150 and that one goes up to 100, so they're actually pretty much the same. Not much happens there. So in that case, OLS will be fine. Right? And quantile regression. Sometimes quantile regressions tell you something that the OLS doesn't, and sometimes not. You don't know until you try.
I'm trying interacting with college grad mom with housewife, I guess. Feeding into this, higher educated women should stay home or take care of their children.
Yeah, I mean, obviously you can do interactions, then it'll be very hard to interpret marginal effects. So it's easy with a regression.
But you know what you can say.
Sorry?
What is the way to do?
Yeah, that's true.
So here's a case with something we've seen in other results where the transition year benefit, if you interpret it causally, doesn't really matter at the top, and to a lesser extent at the bottom. But it's increasing the center of the distribution, dragging forward that middle part of the distribution. And again, with the grinds, to the extent that there is a benefit, it's kind of the kids at the lower end. These kids are, I guess, so smart they can't benefit from grinds. Again, that's a case where it doesn't tell you much that the OLS has told you. Okay, let me just wrap up. So, as I said, unconditional quantile regressions is a method that allows you to model effects on distributions of outcomes, and more often we're interested in that for kind of policy reasons. And so we're applying it to a leaving cert point score. That's an important variable in Ireland. People are obsessed about it. And so what we're doing is kind of going beyond the analysis of the means, what other papers have done. Just to briefly summarize some of our examples, we saw that being a female doesn't affect the left tail of the distribution, but does affect the center and the middle. Being an older, mature student, older, is less important in both tails. That's also true for the socioeconomic gradient, the parental education variables. One thing you can do with this, just like when you're looking at the mean, most of you, many of you will know about Wakaka decompositions, where you decompose a difference in terms of explained and unexplained factors. So you're looking at difference in, say, mean earnings for men and women, and you can break it down into an explained and an unexplained. By explained means explaining it in terms of their characteristics, and unexplained is differences in the coefficients. So this is used to look at wage discrimination. So you can do the same for looking at quantile gaps. Now we've done a bit of this, but we didn't include it partly because we didn't have time. When you look at the gap, I'll tell you in words what we found. Well, if you look at this for male and female, so girls do about, I think, 10 or 12 points better in their leaving. And so you can use our model to decompose that gap into an explained and an unexplained. And the funny thing is that the explained component doesn't help at all, because the explained component has the boys doing better than the girls. So we can explain why boys do better than girls, but in fact girls do better. So the unexplained component is kind of what lands you with an advantage to girls. And so that's for the mean. We looked at it for quantiles. Seems to be the same story, but we haven't really fully got to grips with that. That bombshell.